Today we will be using simulation nodes to create this perfect loop. We've done it using Blender's native particle system, but it's about time we use simulation nodes. We'll go step by step and understand the process, and the applications are actually limitless. So with that, let's actually begin the tutorial. In our default scene, we're going to rename the cube to GeoNodes object because we will be using it for geometry nodes later on. Then we can set up the path from which our particles will be emitted. So let's press Shift A and search for a curved circle, and then scale it up by maybe 5 units, and press Tab to go into edit mode and just change the shape to whatever you like. Let's select these two and press GZ and move it up, and I think that's good enough. Remember, you can choose whatever shape you want, but I'll go with this for today. Then I'll go to the curve properties and just increase the resolution so that it's nice and smooth, after which I'll add in an empty object which is actually going to be following this path. So I'll press Shift A and search for an empty, then axes, and then I'll go ahead and add in an object constraint from the constraints properties. The constraint that I'll use is follow path, and for the target I'll choose the Bezier circle that we just created. Then I'm going to make sure that I choose follow curve so that it also changes its rotation while it moves along the curve, and by playing around with the offset you can make this go all the way around this particular curve. Now essentially, before I start any of the geometry nodes, I want to set up the actual animation. So I'll go to my output properties, change the resolution to whatever I want. Frame rate, I'm going to choose 60 FPS. End frame, I'm going to choose double of whatever I want the actual frame range to be to help make it a seamless loop. So in this case, I'm going to go with 600 because I want it to be a 5-second loop, which means I need 300 frames. So doubling that, I'll get 600. Apart from that, output folder, you can store it wherever you want. I'm going to choose a file format of FFmpeg video, and the encoding, I'm going to change the container to MPEG-4 and the output quality to perceptually lossless. Next, in the constraint properties, I need this to loop twice in 600 frames. So to make it loop twice, I can simply press the back arrow, change the offset to 0 and add in a keyframe, and then on frame 600, I can go ahead and change this to 200 and then tap I to add in another keyframe, after which I can come down here and press T linear so that we get a smooth loop where this actually goes around this entire path twice during the period of the animation. So once we have all of that set up, we can go ahead and actually start the geometry node section. So we'll bring this down again and then bring our cursor to the junction of these two windows, click and drag to create a new window, and change this from the 3D viewport to the geometry node editor. Then we'll select the GeoNodes object, unhide it, and press this plus button to create a new geometry node tree. Now we don't need the group input, so let's select it and tap X to delete it, after which we'll just press this pin button so that no matter what object we select from the outliner, this geometry node tree remains, and we'll also select this so that all of the nodes snap to grid. The tree might get a little long, so snapping it to the grid helps make it look much more organized. Now we essentially want a circle or a sphere from which our particles will emit, and then we want that sphere to follow this particular empty. So let's start off by creating the sphere by pressing Shift A and searching for an icosphere. Then we can just plug this into the group output, after which we can start increasing the number of subdivisions. And if we actually look at this empty object that we have, when it's following the path, it's using the y-axis as the forward axis. So if we want particles to be emitted along only the back faces of the sphere, which means suppose we're at this stage of the animation and we have our UV sphere present right here and it's moving in this particular direction, we would want particles to not emit from this surface, but instead we'd want particles to only emit from this backward direction along the normals of this particular surface. If you want them to move in practically a straight line, you can always use a normal mesh circle instead of a mesh sphere, but I want them to have this sort of a spread to them, so I'm going to use this sphere itself. So I want to delete everything that is less than a certain value on the y-axis because the forward axis is the y-axis. So let's go ahead and do that. We'll press Shift A and search for a delete geometry, and for the selection we have to check the y-axis position of every single one of the points. So press Shift A and search for a position node, and we need to separate out the XYZ. So search for a separate XYZ and plug the position into the vector. Now we need to compare the y value, so let's press Shift A and search for a compare node and take this y value and check if the y value is greater than a certain number, it should be deleted. So let's say greater than 0.3, then we can plug the result into the selection, and this is what we get. Now no, we want it to be far fewer, so let's just start reducing this, and I think this sort of a number is enough, but I don't want it to be this rounded. I want it to be a bit flatter, so I'll press Shift A and search for a transform geometry, plug that in after the delete geometry, and just scale it down on the y-axis to something like this to get this particular shape. Now I want this shape to follow this particular empty, so let's take the empty from our outliner and just drag and drop it into the geometry node tree. Then I'll duplicate this transform geometry node, and I'll simply take this object info node and plug the location into the translation, the rotation into the rotation, and the scale into the scale. Now if we take a look at it, it's actually going in the opposite direction. I wanted the back face to be present, So instead of greater than, I'll just choose less than, and I'll just increase this value so that we get the right face present. So now when you watch the animation, this is what we have, and we essentially want particles to be emitted from this particular face. For that, we're going to be using simulation nodes. So the first thing that we have to do is actually distribute some points on these faces. So I'll press Shift A and search for a distribute points on faces node. Then I'll press Shift A and search for a simulation zone, and I'll plug this points into the geometry and this geometry into the group output. Now everything inside the simulation zone will repeat, so I have to press Shift A and search for a join geometry so that we can join in a new set of points every single frame. So let's plug this into the join geometry, and now when you play the animation, you get this particular motion. Now, of course, this might look cool for specific purposes, but that's not what we want. We require these points to keep changing every single frame. So I'll press Shift A and search for a scene time node, and I can directly plug the frame into the seed so that we get a new seed every single frame, and it looks like a cluster of points being created. However, the problem with this is that it doesn't perfectly loop, because you can see next time there are different points being created. So to make it loop, since we want it to loop every 300 frames, we can simply search for a math node and change this from add to modulo, and then type in 300 for the second value. Modulo gives the remainder after division, so after the frame number reaches 300, it goes back to 1 and continues counting up from there. So now we have something that should be perfectly looping, which means after we get to frame 300, the points that are distributed in the exact same place. So if you look at it, it doesn't look like there are new points being added in, but they're actually being added in the exact same place, which is exactly what we wanted. Now I feel like the overall scale of the place from which these particles are being emitted is too large, so I can select the empty and just scale the empty down to maybe 0.3, and then if you go back to frame 0 and play this, you see that the position from which these particles are emitted is much smaller. But with that, I have to increase the density to get much more particles. So let's increase the density to maybe 1000, and now you have this sort of a distribution. Now we need to start making these particles move along their normal every single frame. For that, we first need to store the actual normals from this distribute points on faces node. So to get these normal values into the simulation input, there's two problems. The first being that we can't just use a normal value from the normal node, because once the points are distributed, they no longer have normals. So we have to use the normal from the distribute points on faces node. However, we can't simply plug this normal into this simulation zone, because everything that's present before the simulation zone is evaluated only once. So we have to actually capture this in an attribute node. So we can press Shift A and search for a store named attribute. Now we can plug this in over here, and then take this and plug this into the input of the simulation input. Now in case we're going to use many more nodes that have to be added in here, I don't want to keep connecting these up. So with the node wrangler enabled, I'm going to press Shift right click and just drag through these to create a new node, so that we can just add in nodes before this, and they'll get distributed to both the input as well as this join geometry automatically. Now what I want is the normal to be stored for every single point. So we're going to have to change this from float to vector, because the normal is a vector, and we can plug this normal into the value of the store named attribute. Now we have to actually name the attribute, so let's name it norm, and now we can use this within the simulation zone. So after the join geometry, let's press Shift A and search for a set position node and plug that in right here. But for the offset, let's search for a named attribute and change this from float to vector and choose the name norm. Then we can take this attribute and plug it into the offset, and now if you go back to frame 0 and watch it play, you can see how every single point is being pushed along its normals. But because the normal is a vector that gives only direction and has a length equal to 1, every single frame it moves by exactly 1 unit, and that causes this repeating pattern. So we have to break that up, and also it's way too strong right now, so we need to reduce that. Let's press Shift A and search for a vector math node and simply change this from add to scale and reduce this value to something like 0.1, so that it moves much slower and we don't have that much of gap between the particles. Next, we need to actually make it such that it's not just moving like this, but it's moving with some amount of randomness as well. So the first way we'll add in some randomness is by actually moving the points from the distribute points on faces itself, so that they're not perfectly on the face but have some amount of variation in the positions. So let's shift all of these to the side and then press Shift A and search for a set position node. Now I want to actually offset it by some random value, so I'll actually search for a noise texture, and I want to multiply the normal with this noise and then plug that into the offset. So I'll press Shift A and search for a vector math node, and I'll plug the color into the vector and the normal into the second socket, and I'll change this from add to multiply and plug this into the offset. Apart from that, I want this to change every frame, so I'll change this from 3D to 4D, and for the W, I'll take this scene time frame modulo value and plug that into the W. So now when you watch it, you have some more amount of variation, and that already looks much better. However, there's still a little bit of a repeating pattern, and if you actually look to the end, you can clearly see how the streaks are formed. So you can see that there is one streak here, one streak here, one streak here, and so on and so forth. So we need to break that up even more. For that, when we set this position, we'll add in some amount of noise when calculating the actual velocity. So I initially want to calculate the velocity so that these particles don't just move in straight lines but move in lines according to their velocity. So I'll press Shift A and search for a position node, and remember, velocity is simply final position minus initial position divided by time, and if we're taking every frame into consideration, it's just divided by 1, so it's final position minus initial position. So we need the initial position, so I'll press Shift A and search for a capture attribute node, and I'll plug it in right after the join geometry. Then I'll capture the initial positions, so let's change this from float to vector. Take this position node and press Shift D and plug it into the value. Now this is the initial position, and we need to subtract it from the final position, which we'll get from this position node. So I'll press Shift A and search for a vector math node, switch it from add to subtract, and I'll plug this position into the first socket, this attribute into the second socket, and now I can plug this into the simulation output, which is going to give me velocity. So I'll go to the node tab over here. If this side panel is not present, tap N to bring it out, and then select this simulation output node, and under the simulation state, you can change the name over here. I'll change it to velocity just so that I know exactly what it is. Now I can actually set position according to the velocity. So I'll press Shift A and search for a set position node, and I'll take the velocity from the simulation input and plug it right into the set position. So now if I play the animation, it should start moving much faster, but we also ended up bringing back the scales. So to remove that, we can now add in the noise that we've been wanting to add by searching for a vector math node and changing it from add to multiply and multiplying in some amount of noise. So I'll take this noise texture, press Shift D to bring it here, and because noise textures are centered around 0.5, I want to bring it back to be centered around 0. So I'll have to search for a vector math node and subtract a value of 0.5 on all of the axes, and then plug the color into the first socket. Then to actually control the amount of noise, I'll press Shift A and search for another vector math node and change this from add to scale, plug the vector into the vector and scale it down by maybe 0.2, and then plug this into the vector of the multiply node. So now when I play the animation, this is what we get, and I think that looks much better, but I'm going to have to scale this up even more. So let's now play the animation, and that looks better. It's much more random and you can't see that alignment, but I can make it even better by changing this W on every single frame. For that, we can take this modulo value again, plug that into the W, and then when we play the animation, this is what we get, and that looks exactly like what I wanted it to be. The next thing that I want to do is actually delete off particles that are too old, because clearly as you continue playing, the number of particles keep increasing and the frame rate keeps dropping, and it gets much harder for Blender to calculate and keep track of all of these particles. So to delete particles, we have to first make sure that we know their age. So I'll press Shift A and search for a capture attribute node and plug that in before the simulation input. Let's plug it in here, and essentially I want it to be an integer for every single point, and the first value is always going to be 0, because when the points are distributed, the age should be 0. Now I can plug this into the simulation input as a new socket, and again just select the simulation input, go down to the simulation state and call this attribute as age. Now every single frame I want the age to increase by 1, so I'll press Shift A and search for a math node, and I'm simply going to take this age, plug it into the first socket of the add node, and for the second value I'm going to change the value to 1, so that way 1 is getting added every single frame, and we can now plug this into the age for the simulation output node. Now we can delete based on this age, so I'll press Shift A and search for a delete geometry node and plug that in before the output of the simulation output, so right here. And now for the selection, I need to compare the age with a number. So I'll press Shift A and search for a compare node, and I'll take this add value and plug it in because this is my age. However, I don't want it to just be greater than some particular number, because that way every single particle will be removed or deleted at the exact same time. So I need to give some randomness to this. For that, I'll use this noise texture itself, but I'll just scale it up. I'll take this, plug it in here, and actually instead of a scale node, I'll use a math node because we don't need it to be a vector, and I'll just change this to multiply. Now I'll take this color value from the noise texture because that is always going to be positive, but if I take it after the subtract value, I might have a negative number as well, which shouldn't be an issue, but just having positive numbers is good enough. Then I'll multiply it by a value because the output from the noise texture is between 0 to 1. So by multiplying it with a large number such as 20, I ensure that the number ranges from 0 to 20. You could use a map range node as well, well, but multiplying it by 20 also works just as well. Now this is my random number and I want to add this random number to a fixed number. So I'll press Shift A and search for a value node, and I'll change this value to maybe 80, and then I'll add this random number to this fixed number using another math node, and then just plugging this into the first socket and this into the second socket, and then plugging this into the compare value of the greater than node. So that way, if the particle's age is greater than 80 plus whatever random number is chosen for that particle, then it should get deleted. So let's take this result and plug it into the selection, and then shift all of this to the side and go back to frame 0 to replay the animation. So now you can see that particles are continuously emitted till we get 80 plus some particular frame, after which particles will start getting deleted. So you can see how the particles are starting to get deleted and they don't cross this particular region because they're all dying. But obviously I think this is a bit too large or too long, so I'm going to reduce the value even more. Let's change this from 80 to maybe 50, and now you can just replay the animation. Now if you're happy with the age that the particle is living up till, you can go ahead and just bake the simulation, because we won't be making changes to the simulation section anymore. So you can go to the physics properties after selecting the geonode object, and then under the simulation nodes you can press bake after you save the file. Then once you press the bake button, the animation should get stored to memory. So once the simulation is baked, you should be able to play back your animation much faster, and you can take a look at what it currently looks like. You can switch off overlays as well, and this is how the particles are being emitted, which looks exactly like what I wanted. Now we can finish off the geometry node tree. So let's go to this group output, move it to the side, and then press Shift A and search for an instance on points node. Then on the actual instance, we're going to use an icosphere. So let's search for the icosphere. We'll reduce the radius to 0.01. Subdivisions will make it maybe 2 or 3, and we'll plug this mesh into the instance. Then for the scale, we'll use a random value, but we'll change the min to something like 0.3, and we'll change the max to maybe 1.2, and then you can plug this into the scale. Apart from that, I do want to store the age so that we can use it in the shader editor. So I'll press Shift A and search for a store named attribute, plug that in right here. The age is just an integer, so let's change this to integer, plug the age into the value, and for the name, type in age or whatever you want. Then I need to actually shade smooth, so I'll press Shift A and search for set shade smooth, and I also need to assign the material, so I'll click on set material and plug that in here. For the material, I'll just choose the default material because we're not using that for anything else. And with that, we should just make sure that everything is looping by going to a random view orientation and then going to frame 300, after which flipping over to frame 600 and making sure that there's absolutely no changes in the position of the particles. So in my case, I can see that on frame 300, it looks exactly like this, and on frame 600, it looks exactly the same, which means if I render from 300 to 600, it will be a perfect loop. To be completely truthful and more efficient at working, you don't require all 600 frames. You could have done 300 plus the lifetime of a particle with some amount of error. So the lifetime is 50 plus 70. So let's give 30 frames as error. So if we just did 300 plus 100, so that's 400, we should have been able to render from 0 to 400 and create the loop between frame 100 and 400. So if you actually look at frame 400 and frame 100, there's also absolutely no difference in the particles. So because of that reason, we didn't actually have to bake up till frame 600. So you can be a bit smart about that, but I find this to be the most satisfying method for me. Now we can start the actual shading section. So let's go to our render properties, switch on bloom, and we'll also just clamp it down at something like 5 and reduce the intensity to 0.03. Then we'll change our viewport shading to rendered, and we'll select our default light and press delete to remove it. Then we'll switch our geometry node editor to the shader editor, and we'll select our geonode object to get the default material present. You can also unpin it because we don't necessarily require it to be pinned. If you can't find the nodes, just tap A to select everything and press period on your numpad to centralize the nodes, after which we can select the principal BSDF and press X to delete it. Now I'll press Shift A and search for an emission node, and I'll plug this into the surface. For the color, I want a gradient, so I'll press Shift A and search for a color ramp node, and I want the gradient to be based on the life. So whenever a particle is just emitted, I want it to be some color, but as it goes towards the edge, I want it to change color. So I have the age stored in an attribute named age, so I'll search for an attribute node. I'll change the type from geometry to instancer, because remember the age was separate for every single point, so it has to be the instancer. For the name, I'll just type in age because that is what I stored the attribute name as, and essentially the age right now goes from 0 to about 70, but I need to change that from 0 to 1. So I'll press Shift A and search for a math node, and I'll simply divide the factor by 70 to make it go between 0 to 1. Now I can plug this value into the factor of the color ramp and plug this color into the emission socket. Now I'm not seeing any change, so let's just see what the node tree is, and we've kept this at add. We need to make it divide so that we're dividing it by 70 so that we get a value from 0 to 1. So now you can clearly see how particles that are newly getting spawned get this left hand side of the color ramp and the older ones get this right hand side. So let's change this from a black to maybe a greenish color. Then for this end handle, we'll change this to a bluish color, and then we'll just increase this emission strength to something like 1000. And because it's clamped, it won't make too much of an issue with the bloom and things like that. But that's essentially all you have to do for the materials. You can go to the world properties then and just change this color all the way to black, after which you can select your camera and press Alt G to clear location, Alt R to clear rotation, and you can also just tap N to go into your side panel, go to view and choose lock camera to view. Then if you press 0, you can just scroll around like you generally would in the 3D viewport to get whatever orientation you want. I think I want to go with maybe this sort of an orientation, after which I'll go to my camera properties, change the viewport display passport out all the way to 1 so that nothing outside the camera view can be seen, and then I'll just play the animation to see what the motion looks like. And if I'm happy with it, I can go ahead and render it. Let's just change the playback from play every frame to frame dropping, and then when you play the animation, you can see what the motion looks like. So I like this particular motion. It's looking good. It's going in that infinity shape, but I want to actually centralize the infinity. I'll just unhide everything, go to the camera properties, composition guides, and switch on center. And now I have this line present vertically as well as horizontally. You can just go back to solid view to see it better, and then I can just move everything till it is perfectly centralized. So I feel like that's a lot better. So now once you're happy with the animation, you can go ahead and press render animation. Hopefully this tutorial was informative and useful, because you don't only have to use it in situations like this, you can also be creative and use it in other applications, maybe such as this situation where you can create the fire from a toy rocket that can follow any path you give it. If you watched so far, thank you so much for watching, because I really appreciate it. The watch time really helps, and it would be very helpful if you watched other videos on my channel, because I post videos every single day and I'm sure there's something or the other that's waiting to be discovered by you. Until the next video comes out tomorrow, make sure to keep creating and stay creative.